Hey everybody, thanks for turning up on a Saturday morning, Bangalore traffic amongst other things. So a little bit of quick show of hands will be very helpful, just in terms of gauging like who's who in the audience. How many of you actively work with data on a day-to-day basis? Okay, that's 90% of the hands going up right there. Okay, how many of you are data engineers? Okay, fantastic. Data scientists? Oh, okay, three of you. Good. We need more scientists. And how many of you work in the streaming space already? Good. So I think we have the right mix of people out here. So just a little bit of an overview of what this meetup group is going to be about. Primarily, we are going to be focused around streaming. So at any point, this is going to be non-partisan, vendor neutral, and mainly this is going to be a platform for thought leadership and sharing knowledge around the worldview of streaming. So we have a lot of other speakers lined up here as well. And since we've gone to a late start, I'm not going to belabor you with too many details, but hopefully this talk should serve as a little bit of a segue to what you should be hearing from the other speakers, but also giving people a little bit of an overview of where streaming is at this point in time, mainly from a practitioner's standpoint, like what you should be knowing when putting hands on keyboard and really being a data engineer in 2023. So with that being said, let's get started. Brief introduction. In my day job, I'm one of the co-founders of Platformatory. We are a streaming focused company. And we work with a lot of the people concerned out here, particularly around Kafka, general sort of overview of distributed systems in the Apache Foundation, sort of line of software. But we also do quite a bit of work around Kubernetes, amongst other things. If you'd like to know more about me, please feel free to connect on LinkedIn, and I'm very happy to network and engage. So for today's talk, I want to begin by doing sort of a proverbial show of numbers. And it's obvious, big data has been big for a long time, like since the early 2000s at least. But measuring sort of how much data there actually exists in the world is a little bit of an exercise in measuring the entropy of the universe. Or it's a very similar exercise. So there are no good estimates, but every email sent, every hit registered on a website ultimately ends up somewhere, right? And that's data. So according to some of these estimates, if you look at this figure, it's absolutely out of the world. About 328 million terabytes of data generated every day. Okay, and if you kind of consider that at a year scale, that's about 120 zettabytes per year. So a zettabyte is basically 1,000 into to the power of 7, or roughly 21 zeros, right? So it's a huge amount of data that we're dealing with, and this data basically keeps increasing year on year, about 20-30% increase. And the point being, the data is not only getting bigger, but it's also getting faster, right? So big data being produced at even bigger magnitudes day on day basically means that the rate of production of data is also ever on the increase. So we've got a problem of not just big data, but also fast data, right? You look at some stats. I think by 2025, this is expected to reach, with the sort of 25-30% increase, about 180 zettabytes. That is a crazy amount of data. And that data is no longer just in the custody of the big digital natives like Google or Facebook, but it's pretty much ubiquitous. It's out everywhere, right? Your bank knows a lot about you. The startup or the company that you are part of probably also has access to a very, very large corpus of data, and it's only getting bigger and faster by the day. that kind of brings us to the problem statement and what streaming is for the most part about. It's not just focused around analytics, because there is a sort of uh, way to application architecture itself, which really models the real world. The world that we live in is full of events, things that occur. All of you just walked into this meeting, the meeting started. All of these things that occur in time are all basically just events, right? And that event primitive is kind of what streaming is so much about, which we will discuss as we go through this talk and as you will hear from the other speakers as well. But in general, I want to tell you, right? There's big data, but big data has traditionally been slow, right? And why it was slow is because of the times that we lived in. But in general, if you were to ask any business leader, literally, right, fast data beats slow data, right? And what do you want to do with that data? Like literally every analytical process or whatever you're doing in your applications is ultimately translating into some sort of business outcome. Okay, and there are really two metrics that you would want to look at, right? First being, some time to insight, right, with the data that's really flowing in. How quickly can you get to that insight? And a second benchmark is how quickly can you translate that into an action, hopefully useful, right? So that context being provided, it's important to talk about how traditional data management has shaped the industry and why there have been sort of pitfalls in taking those approaches and why they made sense at a point in time and why they tend to make less sense right now. So a lot of hands went up earlier. How many of you or the organizations that you work for actively have a data warehouse? Okay. What kind of data warehouses are we talking about? BigQuery. BigQuery. Okay, very nice. Redshift. And how many of you have a data lake? What's the data lake built on? S3. Okay, wonderful. So if you just
could we call S3 data lake? It is the object storage.
It is, I mean, but finally a data lake is basically really based on the foundation of an object store. There's nothing else there.
Then what are the object stores? There all the object stores have the data lake?
Not all object stores are data lakes, but all data lakes are mostly built on top of object stores, right? So you have columnar storage formats, massive amount of data basically pumped in there, with of course certain delivery guarantees around asset semantics amongst other things, and of course there is a way to query that data out in some way. But data lakes basically are very similar to data warehouses. It's a little more schema on read versus schema on write, and a lot of semantic differences.
Schema on read and schema on write is SQL and NoSQL database, not a data lake and data warehouse.
I think it's one of the key differentiators of what differentiates a classic warehouse from a lake. So, but we should come back to that topic. But in general, data lake or warehouse style architectures, not so much the modern ones, but the traditional ones have not really been built for streaming at large, right? And we'll talk through why streaming brings up its own set of challenges. And the point being the sort of explosion of data. Obligatory funny picture of the day. This is Belandur Lake when some of the fires started a couple of years ago. Okay, so the proverbial data lake has always been prone to problems in that the data office leadership was mainly about let's figure out how to get the data into a central place, right? And then let's figure out how to do useful things with it. And invariably what happened as a result of that is that not all, but many data lakes turned into data swamps, right? Where the data lake becomes a black hole where literally the data disappears and there is nothing useful being done with it, except things such as pointless statistics of, we run a huge data lake with, so many petabytes of data and so on and so forth, right? So the utility of data is only so much as in how quickly are you able to generate a useful insight out of it, and at how quickly are you able to turn that useful insight into some sort of actionable business outcome. And why this was so was mainly because at a time, particularly in the early 2000s and even for the most part of the last decade, um, firstly, a lot of organizations were historically on-prem. So how many of you have seen Hadoop data lakes? Okay. So you've seen packaged distributions of Hadoop. It could be Cloudera, Hortonworks, or it could be other things as well. But the point being, it was easy to get data in, but processing data and processing data fast were two very orthogonal objectives, right? And the point about being on-premise was that you always had a lot of constraints, both in terms of storage, computation, as well as networking. So fundamentally, running big data on-premise was a very bad idea. And at that point, not enough cloud adoption had actually been gained to the extent that this would become an economy of scale and it would make it viable in terms of costs. Not everybody could, afford to have a petabyte scale data lake focused operation on-premise. So that leads us to some very foundational shifts as it has been occurring. And this is not just today, everything is a gradual process, particularly you could say since 2014, 15, last 7-8 years, in a very sort of gradual sort of evolution around how people have been looking at data management. So the first thing that comes out of that is almost everything is moving to the cloud, right? And you can see this. You can go ask people who managed some of those big Hadoop data lakes, amongst other things, on premise, or you've had one of those domain data marts in-house running on a huge server, amongst other things. A lot of those are going away, except in certain regulated industries where it's still very relevant. But that apart, one thing very clearly emerges, right? The place for data, all other things, regulatory concerns and everything else being addressed, is firmly in the cloud. Okay, and the cloud really allows you economies of scale and pay for what you use models around how you bring data in, how you store data, how you process data, and how you do useful things with it. A second insight that emerges, and some of this comes up in a McKinsey report that we will quote as well, is that it takes us back to the original question. If you ever ask a business leader, like, how quickly would you like a useful insight coming out of this data? I don't think you will ever hear an answer. It's fine if it comes next week. It's fine if it comes tomorrow. But the reality is that in most organizations, it is indeed offset by a fairly long period of time. For example, in my own working experience, I've worked with a telco where, somebody who manages revenue, their dashboard is probably off by the good part of a day or so. Okay, and that's in a truly digital native organization like a telco. Of course, you can consider a telco as part of the real digital infrastructure. So in that sense, they are definitely digital native. And this dysfunction will look even more apparent and even more stark if you go elsewhere. Okay? So continuously, business leaders are basically making decisions based on stale data, what's probably outdated by hours, potentially days, maybe even weeks, months, amongst other things. So the point is, now that economies of scale, particularly around the cloud, make processing data as and when it comes. Okay, that is basically bringing that delay down from hours to minutes or seconds is something nobody would want to refuse, right? So we'll see a large proliferation of real-time processing use cases, particularly in mission critical ones, because we invariably have to prioritize. Not everything needs to be done real time, but nonetheless, most things that could be done would benefit from it. A third thing that emerges is, in order to kind of do this well, there is a sort of fundamental shift in terms of technologies and tooling that you adopt as well. Through, again, what you've seen through the 90s and 2000s, everywhere else, you've had big software giants who shipped large packaged software, in the sense that it came as an all or nothing package. So therefore, you became an IBM landscape, or you became a Cloudera landscape, or something, or anything else. Having nothing against these platforms, what it does mean is that invariably when you adopt very large packaged platforms, it means that not all of it is good, right? There are parts of it that are really good, but parts of it also come at the cost of mediocrity of some of the others. So therefore, one of the things that's emerged primarily because of cloud adoption is that prospectively you use best in breed for everything, right? And that matters, particularly when your objective is to get the most out of your data in the least possible amount of time. Fourthly, there is a big emphasis on fan out. What this means is basically, the data that's produced has traditionally been with a, how do you put it? It's a single use case view, right? In terms of, I want to get the data from just this application to this specific application for this specific use case. Now, reality is that you have such a large proliferation of use cases that point-to-point connectivity around data is actually going to be a constraint in terms of whatever it is that you might want to do, whether it be it business intelligence or machine learning or just allowing some degree of self-service analytics, whatever it might be. There are multifold use cases for data, and therefore one thing that you would want to look at is data mainly in terms of its fan out. Okay, so how many consumers are you getting that data across to, so that they can do something useful with it, and that must be prioritized over point-to-point connectivity. Fifthly, in terms of more a governance view of how do you build and scale data-focused organizations. Traditionally, organizations have had, this is my department of data engineering, this is my department of business intelligence, this is my department of ML. Now that seldom works out in practice, mainly because if you're in a large organization and if you're dealing with sufficiently complex data, the same rules that apply to large monoliths on the application side of things, that is the complexity of the domain or the context of the problem that you're dealing with is too complex to be simplified into a few models. Okay, it's too complex to be simplified into just a few models. Therefore, everything practically needs to be context driven and domain based. What problem domain are you addressing, right? So that becomes the only way to break the monolith, whether be it on the sort of application side of things where you're doing microservices and things of that sort, or for that matter on the analytics side of things where you'd want to break your data lakes, warehouses, and everything by domain, and mainly adopt a product approach around how you look at data, what use is it serving, whose use cases is it fulfilling, and what is it really required to do. So those are 6 very fundamental foundational shifts in terms of how to look at data in at least this decade. That brings us to why streaming is so important. Right? So the best way to think about um, streaming is to think about your own thought process. The way we think is literally a stream of consciousness, right? So the fundamental thing is in your application, you must think about streaming primitives. What events are actually occurring in my domain? Those are business events, but you can also think about, what operational events are occurring, how they make sense in an analytical context. The fact is that data changes continuously over time. Okay, and being able to look at data as something that's not really frozen in time, something that keeps changing over time, is a big shift in terms of how you model that data and how you set it up for various purposes, whether it's analytical or just doing event-driven architecture, amongst other things. It comes with its own set of challenges, and those challenges, are something that you must negotiate. There is the aspect of sourcing that data from different systems, moving that data so that it can be transformed either in transit or after it's moved. It's a little bit of ETL versus ELT. You have to deal with storage. Is the data lake dead? Absolutely not. Still very relevant and part of fire hosing all this data from operational systems is usually into some long-term durable storage. So you have to consider storage aspects, processing aspects. Processing aspects in the context of batch data is a simpler problem, basically because you've got strictly bounded data. Whereas when it comes to streams, fundamentally it's unbounded in nature. So therefore, there are a number of distributed system problems that emerge and solutions that emerge as a result. How to deal with data that arrived late, for example. Therefore, concerns like watermarking, triggering, amongst other things. What data must be considered, what data must not be considered, how data must be windowed, amongst many other things. And finally, of course, the result of all of this processing is to make that data available in some useful queryable form. And in the context of streaming, it comes again with its own complexities. Finally, of course, you must think about cross-cutting concerns. There is, of course, security. How does one discover this data in an enterprise setting? How do you know that all these pipelines are doing what you want them to do? Security, amongst other things. So again, this talk is not going to be a deep dive. There have been many foundational data architecture paradigms, such as Lambda or more recently Kappa, amongst other things. Streaming aligns much more with Kappa architectures, which we shall probably have more sessions about in due course of time on this platform. But the bottom line is that streaming is a difficult problem to deal with, and it's still not easy at this point. But that being said, it is probably worth it, and over time, it's probably going to get much simpler. So I think we're almost out of time. So I'm going to mostly go through some of these slides rather quickly. What I would encourage everybody to do is to take a reference of some of the Andreessen Horowitz unified data architecture, particularly data infrastructure models. As you can see, the same concerns that we talked about: sourcing data, bringing data in from operational systems where the data actually is born into the analytics side of the house, and dealing with all of these concerns. Right? What you do see emerging there is that data lakes are increasingly paving way for data lake house style architectures, which are more a combination of traditional data lakes and warehouses, in the sense that have access to features like time travel, change streams, amongst other things. Are there any Databricks Delta Lake users out here? Okay, not too many hands going up, but nonetheless, those, and in conjunction with a classic data processing engine like Spark or Flink is kind of where all of this is headed. I think there are three very important archetypes that emerge. And because of the paucity of time, we'll have to take this up later on. But to put it in a nutshell, you have three important use cases. I want to make data very available very quickly for BI, right? I want this to end up on somebody's dashboard, literally. And that again takes a specific flavor of architecture uh, in the streaming world of things. As also something that's more popular, which is classic multimodal processing. I want to do batch pipelines as well as do stream pipelines, and that sits extremely convergently with lakehouse style architectures, whether that could be Databricks. I think we have a talk on Apache Hudi coming up as well, so there will be much more to understand and appreciate out there. But in general, what you'd want to think about is also, like how do I query data out, data that just came in a few seconds ago with sub-second latencies is literally the problem that you want to address. And the solution to that lies somewhere in between classic lakehouse style architectures, which are meant for ingesting large amounts of data, and real-time analytical databases. One of the sponsors for this meetup is also Startree, and you'll hear from them at a later point. But real-time analytical databases is where a lot of real-time analytics happens. So more on that later on. But one of the other beneficiaries of doing streaming first architectures and thinking foundationally about streaming is invariably going to be machine learning, right? So we live in the age of GPT, Chat GPT, and all these other services. And many of them are actually reinforced by human feedback loops, continuously improved with every data point that comes in. That means there are model training, retraining loops, avoiding model drift, so many other concerns. And finally, a streaming backbone is going to be really useful for dealing with all of those concerns as well. There are tons of of success stories around adopting streaming at scale. These are just a few. Netflix, it's just incredible scale, 20 trillion events per day. Twitter is about 400 billion events per day. There are case studies that are linked here that you should see. Even in our own working experience, we've seen organizations that had a time to insight of 2 to 3 days, basically recomputing 500 to 1000 gigabytes of data daily, mainly because of full refresh style data architectures where everything had to be reread and recomputed from scratch. But just switching from that to incremental processing results in basically reducing that time from days to seconds. So it's something that can definitely bring about very tangible business impact. That brings us to some quick closing notes. So if you just went back 7-8 years earlier, I think many things would not look as viable as they are today. So streaming is hot, and that's very apparent in the number of companies that are simply focused around streaming, that are raising funds. It's a very vibrant ecosystem. So some opinionated prescriptive advice here on very ubiquitous tooling. Something that emerges is that Apache Kafka, not just Apache Kafka the software, but Apache Kafka is more of an eventing protocol, and that's supported not just by Kafka but also tons of others. It could be Red Panda or Apache Pulsar or just Azure Event Hub. All of these are basically Kafka compatible in that it provides the necessary streaming backbone for how you think about streams and how you produce and consume data across your ecosystem. The next thing to think through, again, when you're coming into streaming, is how do you transform and process data as and when it comes in. We talked about this earlier. There are many different concerns there around windowing, dealing with late arriving records, so many other concerns. But at this point, I think we have many stream processing engines truly coming of age. So we've had Spark streaming for a while, but there's also Flink, KSQL, Kafka Streams, and a whole host of new age streaming databases like Materialize, Rising Wave, amongst others. It's a very exciting world. You should definitely check it out. And last but not least, streaming is not the solution for anything and everything, but it's always good to think about what converges very well with streaming. And mostly that will be around lakehouse style architectures. We have a talk about Apache Hudi coming up, but consider exploring things like Hudi, Iceberg, or other things such as Databricks, Rhetoric, which are also open source. So our opinionated advice here is mostly around what's open source and what's available for everybody. Finally, there's of course real-time analytics. In that SQL is still the best way to get data out of a system, and that's one of the things that stood the test of time. And that's basically where you have Druid, amongst other things, coming in, literally dealing with the problem of how do I query vast amounts of streaming data at sub-second latencies. So in general, it's an interesting world. Finally, last but not least, we talked about AI, ML. I think the age of convergence of what data scientists typically do, which is go build models and go write code in notebooks, is going to increasingly converge with data engineering and how you deal with sort of the distributed system underpinnings of dealing with vast amounts of data streaming in and being able to continuously refine, improve, and to model operations better. And that's going to be one of the more exciting things that we'll all see in the next few years. Okay, that's my talk. Thank you very much. If there are any questions, I think we should take